Hey guys, it's Miss Johnson and I'm here to bring you our notes for the second half of chapter 1.2. I am starting off on page 37 in your textbook, so if you're following along, you can go ahead and turn to page 37. Today we are talking about some more displays, dot plots, stem plots, histograms, and shape. And we will discuss all of those things and talk about how to describe them using the SOX acronym that we looked at yesterday. We're doing shape, center, spread, and outliers, and also just comparing the displays. So a dot plot, we looked at a dot plot yesterday. Dot plot is probably something that you guys haven't used a whole lot in your math careers. You maybe haven't seen this one before, but this is just another way of marking frequency. It's kind of a cross between like a frequency table and a histogram, because you're really plotting frequency, but they're in the shape of a histogram almost, because they're marked as bars on a horizontal axis. So each data point is marked with a dot along the axis of your graph. You draw this, you have to scale the axis just like you would scale a number line. You go from a minimum to a maximum, and you have to do it in equal increments. You can't change how you mark your increments. And then you mark a dot above the location of the data value. So it's a pretty simple display to make for sure. A stem plot, this is also known as a stem and leaf graph. Some of you used to call this a stem and leaf graph. Or stem and leaf plot. This is where you separate the parts of the number. So you're going to separate the parts of the number, leaving the right-hand digit as the leaves. So the left-hand digit or digits will be the stems, and then the right-hand digit will be the leaves. And the leaves are listed in numerical order from left to right, from the stem on out. You don't put commas or decimal points in your stem and leaf plot. And this is just another way of showing kind of frequency. If I had a stem and leaf plot, you know, I've got my stems over here on the left, my leaves come out over here on the right. If I took that whole stem and leaf plot and turned it on its side, it actually becomes a histogram. I'd have my intervals down here on the bottom, and I'd have my leaves that are like the bars. So if you can kind of picture taking this whole thing and turning it on its side, you would see the leaves up as the bars of the histogram. So the two are very closely related, stem plot and histogram. But yeah, stem plot is useful for us. It actually retains the original data set, which is something that not all displays do. So there's a lot of useful things about our stem and leaf plot that can help us when we're looking at data displays. All right, so let's talk about, let's do an example of creating a stem plot here. So I'm looking at the data set below. It says these data represent the responses of 20 AP Statistics students, and they are responding to the question, how many pairs of shoes do you have? And we're going to construct a stem plot. So again, my stem plot is separating the two parts of the digit. So in this case, all of my data has a tens place and a ones place. So when I separate my digits, I'm going to separate the tens and the ones. The stems that I need, if I look for my lowest data point is 13. My highest data point appears to be 50. Oh, I see a 57. I was about to say 51, but now I see a 57 here. So the stems that I need go from the 1 all the way up to the 5. So if I draw my line down, I've got a 1, 2, 3, 4, and 5 for my stems. Now I'm just going to go through my data. I'm going to erase this so we can read it a little better. I'm just going to go through my data and look for each and put each point down. I'm going to look under each stem individually. So I'll start with the ones. I see that I have a 19. I see that I have a 13, another 13, another 13, and a 15. I want to list those leaves in numerical order. When I list those leaves in numerical order, that means I'm going to have a 3, another 3, a 5, and a 9. All right, so then I'm done with all the ones. So let's look at the twos. Anything that starts with a 2. I see a 26, 26, 24, 22, 23, and another 23. So there's a lot of data points in the twos. So the lowest one is a 2. Then I see 2 3s. Then I see a 4 for the 24, and then I see 2 6s. All right, so there's those. Let's look in the 30s. In the 30s, I see a 31, a 38, a 34, and a 30. So that's a 0, a 1, a 4, and an 8. 30, 31, 34, 38, and I think I got them all. Perfect. Now let's look at the 4s. I see a 49. That's the only one. So I'm just going to list my 9 there. And then in the 50s, I've got a 0, a 1, and a 7. 0, 0, 1, 7. One thing that is super, super important in a stem plot is to list the key. I have to have a key. You can pick any data point in the stem plot. It doesn't matter which one you use, but you need to pick a data point from the stem plot and make that your key. So if I was going to make a key here, I'd have a 1 with a line and then a 3 on the other side and write that that's equal to 13. The other thing that's nice is you can label your graph up at the top. You could also put your label in with the key. Okay, but this is a must. This is the kind of thing that will automatically make you lose credit on an exam if you don't have that part. All right. Oh, the other thing I was going to say about this one, in a stem plot, it's really good to do a little spot check and make sure that you have all of your data points. So I know that my N was 20. I was told that in the description of the question. I could also count my data, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So either way, if you're not told, you could just count your data. But one thing that I'm going to do is count my leaves. I should have the same number of leaves as data points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I have 20 leaves. It's not a total check for accuracy because it doesn't ensure that all of the numbers are accurate, but it at least tells you that you accounted for 20 data points where you had 20 data points in your data set. So when you look at the stem plot here, you see that the stems are going out to the right-hand side. We are going to take those stems and we're going to flip them over to the left. So that's what I'm going to do here. All right, let's take a look at the next one. If we look at a back-to-back stem and leaf plot, it says the two distributions of the same quantitative variable can be compared using a back-to-back stem and leaf. When you make a back-to-back stem and leaf plot, the important thing here is that you're making common stems. Just like we talked about in that dot plot yesterday, we had a dot plot that showed two different distributions. It was the household sizes of the United Kingdom and South Africa. And I talked about how the axes, the x-axis on those two dot plots had to be the same. You had to count by the same intervals and they had to start at the same point and end at the same point. The same is true in stem plots. If you're going to compare stem plots and you're going to make one back-to-back stem plot, you have to have common stems. Okay. So what they did is they separated out this data. They gave us the female data set that we just had on the previous page, but now we also have a set of the male students in that class. So I need to go through and make a back-to-back stem and leaf plot. When you make a back-to-back stem and leaf plot, your stems are going to go down the middle. So when I make my stems down the middle, I need to look for the lowest and highest in each data set. Over here on the left, we already know that the lowest was 13 and the highest was 57. So I need stems from 1 up to 5. But over here, my lowest point appears to be a 4, and then my highest point is a 38. Now this one's a little bit tricky because this is going to be a stem of 0. The tens place is technically a 0 there. So I actually need to go 0 to 3 on that side, which means if I'm going to put the two together on a back-to-back plot, I need to go from 0 all the way up to 5. So my stems in the middle are going to do that. They're going to go from 0 all the way up to 5. Now, the leaves on the right-hand side are not hard to find, or not hard to do. They just go out to the right just like they did on the one we made before. So if I go through, I'm going to work on the males first. So if I go through and list my leaves out, I have a 4, a 5, a 6, a 7, a 7. Oh my goodness, there's a lot here. There's 3 5s. Okay, so let's see if I can get them all. I've got a 4. I've got 1, 2, 3 5s. 5, 5. So I'm done with those. I'm done with that. Then I have a 6. Then I have 1, 2, 3, 4 7s. 7, 7, 7, and 7. And then I have an 8. Okay, that's it for the stem of 0. Ooh, that was a long stem. You got a lot of leaves in that stem. So let's go down to the stem of 1. I see 14, I see 12, 10, 10, 10 to 11, and 10. So there's 1, 2, 3, 4 10s. 1, 2, 3, 4 zeros there for my leaves. Then I have an 11 and a 12 and a 14. Okay, there's my leaves for the 1, the stem of 1. Then I'm going to go to the stem of 2. I see a 22, and that's my only one there, so that's good. And then I'm going to go to the stem of 3, and I see a 35 and a 38. So 5 and 8. That's all of my data points. Let's count them because I'm not quite sure if I have them all. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So this also was an N of 20. Let's count our leaves in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Perfect. Okay, awesome. Now let's go back to the females. So I want to just look back at this previous slide that we had our stem plot. I'm going to take my stems and I'm going to flip them over to the left. So my stems that I just had on the right-hand side, I know I have nothing in the zeros. I need to go back to my 1s. So I have the 19, 13, 13, 13, 15. Did I get them all? 3, 3, 3, 5, 9. These stems are going to go backwards. They're going to go from right to left, which is opposite on how we read things, but we're working from the stem out. We want to have our numbers that are closest to the stem actually literally be closest to the stem. So I got a 13, I got a 13, I got a 13, I got a 15, and I got a 19. Did that work? I think it did. Are there any more 1s? I think I'm good. So let's go on to the, I put those in the 0. My bad. Let me fix that. 3, 3, 3, 5, 9, and erase. Come on, Johnson. Sorry. Okay, moving on. Let's go to the stem of 2. So in the stem of 2, I had a 26, 26, 24, 22, 23, 23. So there was that 22, then 3 and 3. Is there another 23? Why did I think there were 3 of them? No. 24, and then 26 and 26. 26, 26. Okay. Then 30s. If I go to the next stem, I've got a 30, I've got a 31, a 34, and a 38. So a 0, a 1, a 4, and an 8. 1, 8, 4, 0. Okay. 40s, I had that 49 and it was the only one there. 50s, 2 50s, a 51, and a 57. So a 0, a 1, and a 7. All right, let's count. I know that this N was 20 because I was told that in the previous example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Perfect. Okay. Last but not least, you have to have a key. So when I list the key out, the key should be the same for both sides because you're using common stems and you're splitting your numbers in the same way. So the key, you can pick any data point. You could pick the 4, you could pick the 38, you could pick the 49 from the left side. It really doesn't matter which data point you pick. Just pick some data point from the set. If I use that 13, I'll keep it the same. I'll do 1 with the line and then 3, which is equal to 13 pairs of shoes. Also would probably be a good idea to label the top of shoes, and you can put even who is on what side. So this was males, and this is females. All of that just provides more context, which is important in this class. All right, so sometimes when we're making a stem and leaf plot, it's hard to see a comparison of our data when our leaves get so long. So we are going to talk about how we can also split up our stems in groups of 2. I'm not going to use the female and the male data that we had from our previous example. I copied those tables over here, but I'm going to use a different example as well. If you're looking in your book, I'm looking at page 39. Up at the top, there's an example that talks about splitting the stems apart. They gathered a bunch of data on helmet size. So they were looking at the measurements of head circumference in inches from 30 players on a team. So when they made their stem and leaf plot, the original stem and leaf plot looked like this. The stems were 20, 21, 22, 23, all the way up to 25, 24, and 25. And you can see the leaves there. There was 2 8s, and then a 0, 5, 6, 7, and 9. And this 2 was the really, really long one. 0, 2, 3, 4, 2 5s, 2 6s, 3 7s. This 23 was a long one as well. 0, 0, 1, 3, 4, 5, 5, 9, and 9. And then 24 was 0 and 2, and 25 was 6. So what happens here is we can split up these stems so that it's a little bit easier to see our data. So if I took these stems and I split them apart instead, it's kind of like taking the 0 to 4 and putting them in one group, and then taking the 5 through 9 and putting them in another group. So I'd have a 20, and then a 20, a 21, a 21, 22, 22, 23, 23, 24, 24, 25, 25, and a 25. Okay, that's a 2 there, sorry. And so when you expand those out, you see a little bit better picture of what's going on with your data. If I expanded out this one, my 8s both fall in this second group, because again, this would be like 20 to 24, or the 20.0 to 20.4, sorry. And then this would be 20.5 to 20.9. So that's why my 8s fall in there. If I split the 21, I'd have a 0 in the first group, and then I'd have the 5, 6, 7, and 9 in the second group. If I split the 22, I'd have a 0, a 2, a 3, and a 4, and then I'd have the rest, 5, 5, 6, 6, and 3 7s. If I split the 23, I have 2 0s, a 1, a 3, and a 4, and then the second one down would be a 5, a 9, and a 9. Splitting the 24s, I actually only have 2 points in the first group. So then this group has nothing, no data. And then the 25s, similar problem. The first group has nothing because there's nothing in the 0 to 0.4, but then the second group has a 6. So those 2 stems would be empty, but that's okay. That gives us a good picture as well. So it's just nice to see a little bit better picture of the data when you split it up a little bit more versus having one really long leaf there and one really long leaf there. So we talked about describing shape yesterday. We talked about how things could be symmetric. We talked about skewed to the right and skewed to the left. And we talked a lot about how skew follows the tail. You're going to continue to use that when you describe stem plots or histograms as well. It doesn't just mean dot plots. We looked at these pictures as well yesterday. Other types of descriptions like uniform, bimodal, bimodal with symmetric, unimodal with a peak. So now let's take a look at some histograms. So it says a histogram shows the intervals of values as a bar. The heights of the bars show the frequencies or relative frequency, if you're looking at percentages, of each values in the interval. So what we're looking at here in these two in this example is the left-hand side is a dot plot, and they took that dot plot and just turned it into a bar. So anything that fell from 1.5 to maybe 1.7, and then 1.7 to 2. Or 1.75, it must be right in the middle, and then 1.75 to 2.0 became a bar. So all of these are intervals that are including groups of data. The cool thing about a histogram is that when you create a stem and leaf plot, you can take that stem and leaf plot and turn it on its side and get a histogram. I think I mentioned that a few slides back, but those two things are very closely related. It's also really easy to take a dot plot and turn it into a histogram. One thing to note about the histogram, and we talked about this back when we were talking about bar graphs a few days ago, notice that there's no space between the bars. One interval butts right up next to the next interval. So there's never any gap in your data when the data goes one right to the next. The intervals are all connected. Okay, so there's no space there. Let's take a look at this histogram here. It says how to make a histogram. We want to choose equal width intervals. That's important. Make a table that shows the frequency. So it's nice to see the frequency like they have there for each interval. So this is our frequency table that we made. Draw your horizontal and vertical axes and label them. So there's your labels. You're going to scale the axes. These are just like drawing a coordinate plane. When you draw a horizontal and vertical axis for a histogram, it's just like making a coordinate plane. It's really important that your axes are equal. You have to scale your intervals the same way all the way along. Draw the bars above the interval. The bar heights correspond to the frequency or relative frequency if you're looking at percentages. So you can see that this looks like frequency, not relative frequency. Yeah, they say count over here. But there's your bar graph. And then, or there's your histogram. And then you could describe it. We could take this and describe this. I already know looking at it that it's skewed to the right. Okay, the tail is off to the right. I see that there don't appear to be any outliers. I could determine where the median is by looking at how many data points I have. I'm looking at 50 data points. That means my median is the 25th point. So if my first bar goes up to 20 and my second bar goes up to 14, this would be 20. This would be the 34th data point. Your median is going to be somewhere in here. So I could say the median falls between 5 and 10. You can talk about the variability. You can say the histogram goes from 0 to 30. All of that. All right, so histograms and bar graphs are different. Histograms measure quantitative data, or in other words, numbers. Bar graphs measure categorical data, or in other words, word answers or categories. Use percents or proportions instead of counts on the vertical axes when you're comparing distributions with different numbers of observations. So if you're looking at one distribution that has 100 data points in its sample, but you're looking at another distribution that has 20 data points in its sample, it doesn't make sense to use count because those don't relate to each other. A data set of 100 and a data set of 20 are two different things, and your histograms are going to be very disproportionate. If you turn them into percents or proportions and make it relative frequency, the very word relative should tell you that you're making them relate to each other. That's what allows you to compare those two distributions. And then it says, just because a graph doesn't look nice doesn't make it a just because a graph looks nice doesn't make it a meaningful display of data. We talk about this a lot. Data is raw in this class. It's real. It's not always going to be pretty. It's not always going to look really nice. Just because something looks really nice doesn't mean that it's a good graph. You need to make your data accurate, and sometimes that means it's not going to look really pretty. Okay, one really important thing. When you are making a histogram, it is going to be to your benefit to practice doing this on a TI-84. We don't always have to make histograms by hand. We're often going to have to draw those histograms by hand, but you can have it created on your calculator, and then your calculator will give you the intervals that are appropriate and the counts all the way up. in your calculator, if you go and click on the Stat button and then the Edit button, this is going to be something we use in this class all the time. Entering our data into these lists, that's why it's an L, because it's the first data list, that's going to be something that we do a lot. So we're going to go through these steps, and I want you to practice these things on your calculator so that you can practice typing it in, because that is something that you're definitely going to need to do on your own. So I go into the Stat Edit menu, I go into List 1, I enter my data in there. It does not have to be in order. You don't have to put your data in order. Your calculator is magical and it will do a lot of things for you. Then you'll go to Stat Plot, which is above the y equals. So you hit second and y equals. You're going to enter into Plot 1 and select the options that we want. Then you're going to hit the Zoom button, which is also on the top row, and Zoom 9 is Zoom Stat, and that's going to give you the picture in your menu. All right, so let's talk about how to do that with this histogram. So I'm going to construct a histogram of the data below, and I'm going to use my TI-84. Okay, so in your TI-84, hit the Stat button, hit the Edit option, which is the very first one. And under List 1, hopefully you have no data in there. If you do have data in there, if you arrow up and then hit Clear and then arrow back down, your data will disappear. Don't hit Delete because that deletes the list, but if you hit Clear, that will clear the data. So now I'm just going to go through and type these in. 9.95, 10, 2.25, 16.75. All I'm doing is typing the list. 19.5, 22.5, 7.5 all the way down. 12.75, 5.5, 11, 10, 20.75, 17.5, 23, 21.9, 24, 23.75, 18, 20, 15, 22.9, 18.8, and 20.5. Okay, so I'm on the 26th. You should see L1 and then with a 26 inside parentheses. That means that that's the 26th line that you're on, which means that you entered 25 data points. If the next open line that you're on is 26, you've entered 25 data points. If I count here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 5 times 5 is 25, so my N was in fact 25 here. So that tells me that I at least got all of the data. Okay, so now I'm going to turn my stat plots on. So the first thing that I did was, step 1 was Stat, Edit, L1. 1. The next thing, you're gonna hit second, y equals, and plot 1. That's gonna turn your stat plot on. So I wanna turn my stat plot on. Make sure you flip that option to on. Then the next option down, you want a histogram. For me, it's the third display over, but you're looking for the little icon that looks like a histogram. So again, for me, it's the third one over. So arrow until you can get on top of that and then hit enter so that it's selected. The X list is L1 because that's where we put our data. If you're using one of the fancy new calculators and you have an option of picking the color that you want it to be, go ahead and do that if you want. It doesn't matter what color you use. It doesn't matter if you want to pick it, go ahead. So I've turned my stat plot on, I've picked the histogram option, and then I've used the L1 list. Now I'm gonna hit that zoom button. So the next thing you need to hit is zoom. And the option you want is 9, which is stat plot. You can either arrow down or you can just hit option 9. When you do that, it's gonna take you straight to the histogram. And my histogram looks like this. The other button that's really awesome and helpful for us in here is the trace button. If you hit trace, then you can arrow to the right and to the left, and it will tell you the intervals. So my histogram looks like this. My minimum is 0 here, and then here, let me switch my colors. 0 here, and my max is 4, and that frequency is up at 2. Okay, then if I arrow to the right, I go to the next one. I'm going from 4 to 8, and that frequency was also 2. Arrow to the right. Then I go from 8 to 12. Notice that my intervals have been the same. Ooh, I'm gonna run out of room. My histogram's gonna be really tall, sorry. From 8 to 12, my count was 4. From 12 to 16, my count was 3. I'll mark my 4 there. Then from 16 to 20, my count was 5. So if I kept going, sorry, I'm in my table now. I made my graph too big. My count is 5. So this is 16 to 20. Oops, too far. Undo. Go up to 5. Then I have 2 more left. 20 to 24 this is my biggest one, 8. And you go all the way up to 8 here. And some people even label the top of their bars. I'll show you what I mean. Oh, that was 24, sorry. And then 24 to 28 is a 1. So this one's a little baby guy down here. Some people like to go through and label the counts at the top of their bars. So this was a 2, this was a 2, this was a 4, this was a 3. You don't have to. You certainly don't have to. But some people like to because it gives them a better picture of what they're looking at. All right, so there is me making a histogram. Sorry, my histogram got stuck a little bit into my table. I would go ahead and label my axes. My vertical axis is the number of hours my classmates spent video. So number of classmates, that's number of people that fell into that category. And then the horizontal axis was hours playing video games. Okay. And there you have it. There's your histogram. Bars are connected, intervals are labeled, intervals are equal, and all of that. All right, that's it today. Thanks for listening, and that takes us to the end of section 1.2. So thanks for listening, and I will catch you next time.